Good day everyone, I am Eugene De La Cruz and I will be discussing how to solve assignment problems. So let's consider this problem. A computer center has 4 expert programmers and needs to develop 4 application programs. The head of the computer center estimates a computer time in minutes required by the respective experts to develop the application programs as follows. Find the assignment pattern that minimizes the time required to develop the application programs. So this problem is actually an example of an assignment problem because there are 4 programmers to be assigned to the 4 programs and we are looking for the assignment that will minimize the time required. So in solving assignment problems, we will be using the Hungarian method. So the first step for the Hungarian method is to subtract the smallest number in each row of the original cost table from every number in that row. So this table is what we call the opportunity cost table. So the smallest number in the first row is 80. So we'll be subtracting 80 from each number in the row. So 80 minus 80 will obviously be 0. 120 minus 80 is 40. 100 will be 20. And 90 will be 10. For the second row, the smallest is 70. So it will be 0. 80 will be 10, 90 will be 20, and 110 will be 40. Next, the smallest in the third row is 100. So it will be 0, 110 will be 10, 140 will be 40, and 120 will be 20. For the last row, the smallest number is 80. So it will be 0, and 90 will be 10, and all of them will be 10, since all of them are 90. So this will be our new opportunity cost table. The next step is to subtract the smallest number in each column from every number in that column. So in the first column, the smallest number is 10. So we will be subtracting 10 from each number. So 10 minus 10 will be 0, 0, 0, and 40 minus 10 is 30. For the next column, the smallest number is also 10. So this will be 0, 20 minus 10 is 10, 10, and 40 minus 10 is 30. For the next column, since the smallest is 0, and there will be no change, since if we subtract 0 from any number, it will still be the same. And similarly to the last column. So this is already our new opportunity cost table. The next step is to test the table resulting from step 1 to see whether an optimal assignment can be made. So the procedure is to draw the minimum number of vertical and horizontal straight lines necessary to cover all zeros in the table. So in this case, we will have to cover all of the zeros using horizontal and vertical lines. So for column A, since there are 3 zeros, we can cover all of that with one line. And similarly, here in the last row, since there are also 3, though this one is already covered, but there are 2 more that is uncovered, so we can cover that with one line. Column D also has 2 uncovered zeros, so let's also cover that with one line. So now we are left with this one, which we can cover with this line. So now, all of the zeros are now covered with lines. So the next step, if the number of lines equals either the number of rows or columns, an optimal assignment can be made. But if the number of lines is less than the number of rows or columns, we proceed to the next step. So let's count the number of lines. So 1, 2, 3, 4. So since there are 4 lines and there are 4 rows, therefore this is already an optimal assignment. So to give the assignments, we will be looking at the zeros that correspond to each programmers or program. So for programmer 1, there is only one zero, which is C. So therefore, we will be assigning program C to 1. So 1 to C. So programmer 1 is now occupied and program C is also occupied. So now we can see that this 0 is the only one that program B have. So we'll be assigning programmer 4 to program B. So 4B. So, so program B is now occupied and programmer 4 is also occupied. So we are now left with programs A and D. So as we can see, it can work either way. We can assign 2 to A, and 3 to D, or 3 to A, then 2 to D. So either way, it will work. So let's assign 2 to A and 3 to D. So now, there is a one-to-one ratio with the programs and the programmers. So therefore, this is already an optimal assignment. So to get the total cost or the total amount of time, we must refer back to the original opportunity cost table before we subtracted anything from it. So by looking at the assignments that we made here and comparing it to the original cost, we can get the total cost of the assignment problem. So by adding 80, 80, 100, and 90, we can see that the minimum amount of time for this assignment problem is 350 minutes. But what if we assigned 3 to A and 2 to D? We can see that it still yields the same the total value of 350 minutes. So whichever one we went with earlier, we would still arrive with the same answer.